Hello and welcome to C++ Weekly. I'm your host, Jason Turner, available for code reviews and on-site training. Going to take a moment again to remind you to check out the video description so that you can see upcoming workshops, classes, t-shirts, books, all the things that are available to help support this channel. Now, I often get asked, hey Jason, why haven't you done a video about X? And usually it comes down to one of two reasons. X, whatever that happens to be, would be very difficult to make a succinct 10 to 15 minute video about, or there simply isn't any compiler support for it yet. So if you want to know things that are potential topics for C++ Weekly, you can check out the compiler support charts on CBP reference. These are almost always up to date, and these are the things that I'm looking at for upcoming episodes. Which brings us to today. Basic string, resize, and overwrite. Okay, so I must say it was not immediately obvious to me why this function was added to standard string. Let's go ahead and play with it. I am on GCC trunk, I am in C++23 mode, and I am using Compiler Explorer because that is almost always what I am using when you are watching these videos. That is compiler-explorer.com or godbolt.org, an immensely powerful tool and arguably a critical piece of C++ community infrastructure today. If you don't know about Compiler Explorer, be sure to check it out. I'm going to actually get rid of the compiler output window for a moment. We're just going to focus on the assembly, and we're going to see what some options are here. Now, the idea of resize and overwrite is to kind of stop this two-step, if you will, that we have been doing when we write C++ code. So we might do something like this. Construct it, resize it, and then fill it with data in some fashion. Note when these values get created, these 10,000 characters that are the string, it has to basically do a malloc, new, here's the new, for 10,001 because it must have the null terminator as well. And then it does a memset and it copies the byte 0 into these 10,000 memory locations. If I were to have done it this way instead, where I initialize it with 10,000 A's, then we should see a similar call to memset with the value 97. Okay, same idea. It accomplished the same thing. So we've constructed this thing, but now we need to fill it with some sort of meaningful data. And the documentation for this function says that it was intended for constructing of objects that were the result of some other function call. Like say, for example, they are string objects that are constructed with the result of something like an fread, something like that. So interacting again with C APIs, similar to the in pointer and in out pointer from a few episodes ago. So I'm not going to do that though. I'm going to do something a little bit more synthetic just to see if out of curiosity we can actually follow along at home here. Okay, I am just taking some character and I'm basically doing like a rainbow striping of this data. The characters will go from 0 to 255 over and over and over again. And we should see some interestingly unrolled, flattened out chunks of strings that will be copied in blocks. Ooh. Note, Compiler Explorer strongly recommends that you do not do mark equals native. See? I don't care right now though. So this actually did make some SSE unrolling of the striping of data fascinating. And we'll see if we get anything different from a different version of this. Okay, so the resize and overwrite is intended to do this all in one go. And basically, we construct our string empty. And we're saying that we want to construct 10,000 of these. And then we're going to pass it some sort of callable object. Now, the function does need to return the new size of the string when it is done, because it's possible that capacity is different than size. All right, so let's go ahead and do our same little unsigned character rainbow striping thing that we had been doing. All right, it appears at first glance to have generated extremely similar code. It is constructing this thing, and then it is doing the allocation, but it should be able to avoid that mem set. And yeah, we are avoiding the mem set and doing the mem copy. And if we go back to our original version, then we probably see that mem set happening. Yes, the mem set is happening here. So that is the difference. With resize and overwrite, we can avoid that potentially very expensive mem set, but also hopefully make our code actually ultimately more understandable, and that we are indicating to the reader of our code that the goal is to resize the string, and we don't need that data initialized. We are going to initialize it ourselves. So hopefully that made sense. That is resize and overwrite on standard string from C++23. And all of our compilers support it today. And my understanding is that we did not get similar behavior from vector. And I see that some people were in fact interested in that as well. So just so you know, I did just try to run this with Quickbench, but Quickbench does not yet let me choose the C++23 flag. So I can't test this, unfortunately. But before I wrap up, I think that it is worth pointing out the actual use case that the writers of this proposal had in mind. And it's honestly not that dissimilar from what I did, but the idea again is that we are going to create the string and then do the resize and overwrite of that data in one step, avoiding that extra mem set. So thanks for watching this episode of C++ Weekly.